Welcome to our mathematics class. We are now looking at the basic examples using trigonometric functions, and this will be our part 1. Now let us look at an example. If cos alpha is equals to 4 divided by 5, and alpha is between 0 degrees and 90 degrees, then determine the value of each of the following. Number 1, sin alpha. Number 2, tan alpha. Number 3, cos squared alpha plus sin squared alpha. Now, let's look at the solution for each. Given that cos alpha is 4 over 5, that implies that the adjacent side is 4 units and the hypotenuse side is 5 units. And putting that to a diagram, we would show angle alpha and would show the hypotenuse side as 5 units and the adjacent side as 4 units. Since it was mentioned that the angle alpha is between 0 degrees and 90 degrees, then our triangle would be in the first quadrant of the Cartesian plane. Now, we need to calculate the unknown side, which is the opposite side. And in this case, Pythagoras theorem would be in a position to help us, since this is a right angle triangle. Now, according to Pythagoras, AB squared plus OB squared equals to OA squared. Now that we are looking for the unknown, which is the opposite side, and it's AB, we would now transpose and make AB the subject of the formula. So AB squared is equals to OA squared minus OB squared. Substituting the values where OA is 5 units and OB is 4 units. Then from this case, we would apply our knowledge of exponents. 5 squared will give us 25 and 4 squared would give us 16, and the difference thereof would give us 9. AB squared equals to 9, and then finding the square root to yield AB. AB is equals to the square root of 9, and finally AB equals to 3 units. So in this case, we would say our opposite side is being found as 3 units. Now we would find sin alpha as requested, but now let's look at where we will draw our values from with the updated diagram showing that the opposite side is 3 units. We know that sin alpha is opposite of hypotenuse, so the opposite side we know it to be 3 and the hypotenuse side is 5. Then that yields that sin alpha is equals to 3 over 5. Finding the second one, tan alpha. Now we know that tan alpha is opposite over adjacent, and then we would replace the opposite side with 3 units and the adjacent side with 4 units, and that would yield that tan alpha is equals to 3 over 4. Looking at the next one, cos squared alpha plus sin squared alpha. Now let us use the diagram to draw our values from it. Now we know that cos is adjacent over hypotenuse, but since cos is squared, that would be adjacent over hypotenuse squared. And then knowing that sine is opposite over hypotenuse, that would be sine squared would yield opposite over hypotenuse all squared. Substituting the values, we will get 4 over 5 squared, since adjacent side is 4 units and hypotenuse side is 5 units. And then the opposite side over hypotenuse would yield 3 over 5, and then we square it since it's a sine squared. Then we get 16 over 25 plus 9 over 25. Then add fractions, we add to the numerators 16 plus 9 since the denominators are the same, and then it yields 25 over 25, which yields 1. And this is the conclusion of our example. Looking forward to seeing you in part 2 of our examples. Enjoy the rest of the day.